Welcome everyone to Knox Game Design for June 2026. My name is Levi Smith. This month we're going to be talking about NES photographics. That's graphics for the Nintendo Entertainment System. So when I was a kid, my first game system was the NES. Back in the 80s, and one of the things that really amazed me, some of the games that I saw, some of the games that I played, I got a few examples shown here, how they could use like photo graphics in those games. That always amazed me. Some of the examples like Batman, how they had Batman on the main title screen and the Batmobile in the game, RoboCop, him standing there, and then the Three Stooges also on the title screen, and Bill and Ted's Excellent Adventures, among many other games that used these photographics in the games. And I never really understood how those were created, but I'm going to show today how you can actually create your own photographics for your own NES games. So here's some of the tools I'm going to be using. First of all, Gimp. I've used Gimp for a while, drawing graphics tool. Primarily going to be using that for resizing the image and converting the palette, getting the image prepared. And then I'm going to be using a tool called NESASM. There are other tools out there. This is going to be used for compiling our game, our assembly into an NES game, NES ROM file. Used this years ago when I did a talk for creating NES games, and it's still available, still out there for free. I really like the tool. Another one, YY-CHR. That's what we're going to be using to creating the texture palettes with the tiles and converting the graphics into NES format. Then finally, FCEUX. That's the NES emulator that I'll be using. However, at the end, I have a demo that I'll be showing how to actually run our demo game on actual NES hardware. So that'll be at the end. So here's a little bit of a review for NES assembly. First of all, here's the assembly for defining the background. This is just going to display our image to the background. So that's what all these long hexadecimal strings are. So that's going to be the tiles to display to the screen, to the background layer. So for an NES game, you have like the sprite layer, then the background layer. So we're just going to focus on the background layer for this example. You also have the palette. This defines what colors are used to for your image. So you'll see you have two lines here, each with 4 groups of hexadecimal characters. So the first line is your background palette. So you have 4 different palettes for the background layer, and then the second line is the sprite palette. So you have 4 different palettes for the sprite layer. So I just have all these set to black for the sprite layer. And then you have the attribute definition down here, which is in binary, and this is just basically telling the background which palette to use, and so it's basically in 16 by 16 chunks, which palette to use for each of those. And I always recommend, like in my original NES programming video, to check out Nerdy Nights at Nintendo Age. That site is no longer around, but it is archived. So yeah, I'll put a link, but if you go to nerdynights.nes.science, here's the link to the original Nerdy Nights series of posts that goes into developing an NES game using 6502 assembly. It's really good. Here's like an example right here of the palettes right here in the Nerdy Nights tutorial. So you got to know a little bit of assembly, but it kind of holds your hand through creating your own game. Here's the thing about the background palettes and the attributes and all that. So, but this talk isn't about making an NES game. This talk is just going to be about the putting a photographic in an NES game. So I started out with an image of myself here. Took this, I think, a couple of years ago when I was down at Georgia Tech. You can see Tech Tower in the background. So just a picture I wanted to use to put into a game right here. Like I said earlier, the first tool I'll be using is Gimp. So the first step is scaling this image down to 128 by 128 pixels. That's the maximum size you can have for a background layer, texture layer at once. You're going to have additional graphics, but that's most at one time. So the NES for NTSC televisions, the maximum resolution is 256 pixels across by 240 pixels down. So you'll never be able to have a background texture as large as a screen. So there's ways to get around. If you want to fill up the whole screen, you can do tile flipping if you have a symmetric image, or like if you have empty spaces, you can just fill that in with a empty texture, an empty tile. That way you can save those tiles for other things, but won't be getting into that as much today. But so the first step is reduce it down to 128 by 128 pixels. Then I recommend converting it to grayscale. I always get a better picture after converting to grayscale. We're going to reduce this image down to 4 colors because that's the most you can have on a single palette at any time. And one of those colors is going to be the background color. So you may really only want to use 3 colors. We're going to copy it. That's one of the beauties of this YY-CHR program. It's an older program, but it still does a great job. You can paste directly that image data directly in to the YY-CHR program. Then we're going to save that as a CHR file. That's the file format used in NES games for the texture data that gets read into the assembly source code file. Then, like I said, we're going to import that into our ASM assembly file after we do that. Yeah, so here we are in Gimp. Go File, Open, and I'm going to open up this Knox LD Smith Ridge file. So I'm going to have all these files up in the source code repository. So you can see right here, our size is 300 by 300 pixels. So that's going to be way too big. So you just go to Image, Scale Image, then 128 by 128, scale that down. And the next thing I like to do is go in color. I think you can do this one of 2 different ways. There's a desaturate color to gray, or you can do saturation directly. So I think usually it may turn out to be pretty much the same, but either way, you can turn that into a grayscale image right there. So here's the important part. Going into image, you go into mode right there, and we want to do indexed, and I'm going to do 4 colors. So convert that. So yeah, it's not going to look as detailed, but that's just kind of the way things work with NES games. It's kind of like the old retro style graphics. So we're going to do Control A. We want to select all this, make sure our selection tools selected. Then we're going to copy, Control A, and then copy. And then here is the YY-CHR program, that guy right there. It's a great tool. The only complaint I have is like you can't make the window any bigger. You're kind of locked in right there. So this is like the first sprite layer right here. Then if you scroll down, that's like the background layer right there. So I just want to kind of get that right there. Then just paste it in with the Control V. I think you can do edit paste as well. So yeah, it's going to look kind of weird because it's using the default palette, but you can click right there, pick one of the other palettes, and it'll change. So this really isn't that important. I mean, you just want to make sure it kind of looks right because we'll actually be coloring it in the assembly itself. So this isn't that important right here, but you can go in here and change the colors, like the background, and like that for each of the colors. and just play around with it. Like I said, this isn't that important for right now, but you can kind of get an idea of what your image is going to look like. So yeah, all you need to do is File, Save As. Then we're going to save it as a CHR file. Yeah, so this is the demo folder right here. So you can just save it as Knox.chr like that. I'm just going to cancel since I already have it saved. So then you just need a text editor. You can do this in Notepad++. You can do it in Visual Studio Code, which is what I'm using right here. You really don't get any highlighting or anything additional in Visual Studio Code. But yeah, I took this example directly from the Nerdy Nights right here. So this is like all the template code right here. I'm not going to get into all the assembly right now, but just be aware, like this is where we're loading the palettes right here. And we're loading the sprites right here. And here's where we're loading the background data, background loop 1, background loop 2. Here we're loading the attributes right here. It's going to jump forever. Then you have this non-maskable interrupt that gets called on basically every frame. And down here's where we have, like I said earlier, our palette data, our sprite data, and background data down through here. So I'm just, and attribute data right there. So I'm just kind of showing that just to show that's what it looks like. Okay, so this is our code right here. So yeah, Knox ASM is what I was just showing. Knox CHR is our tile data type build.bat. So this is basically kind of like my little make file just for Windows. But here's my NESASM 3 executable, and actually copy that, paste that in. Yeah, you can just run it right here. You can see NES Assembler version 3.1, and it gives you some of the command line switches right here. But yeah, basically, we're just going to run NESASM3 on our Knox.asm. Then we got our out directory. Then we're going to move our NES file to out. And the older version created a temporary file. That's what that was deleting right there. So I'm just going to do build.bat. And then cd out. Look at it. Yeah, so here's our file that we just created. Knox.nes. So the next step is to actually run it. So I got FCEUX right here. I'm going to open, find our out file, says Knox.nes. So yeah, there it is right there running in an emulator. So I really didn't I just had some random attributes defined, palette data. I don't think I filled in the bottom right here, but yeah, just define some areas and just an example palette for coloring this. So yeah, this is what I was talking about with YY-CHR. Want to make sure that the format is 2BPPNES, which I believe is the default, and I had to change it. You want to save it to generate your CHR files. You can play around with the palette colors, and you'll actually define those palettes within your assembly. So you can use this palette to figure out what the hexadecimal code for each of the colors are that you want to use in your assembly file. But this, I guess the point I'm trying to make is this does not save attribute data, at least as far as I've ever used it. This does not save attribute data in your CHR file. Also wanted to mention that you can find, I'll have all these links out there, but NESASM is developed by Cluster M. It's available out here. You can download it right here for Windows. Latest release was May 31st, 2021. You can get it right here. You can get the source code and compile it yourself if you choose to do that. YY-CHR is on romhacking.net with the download right here. Last release was March 8th, 2012, so it hasn't been updated in a while, but yeah, as some people say, it's still a great tool, even after all these years. You can download that right here. I don't believe it has an official site. The author is actually named YY. Oh, link. So, oh, okay. So there is actually an official page in Japanese for YY-CHR, which is, oh, cool. Yeah, I did not know. I'll put a link to this out there as well. But wow, if you can read Japanese, there's actually Japanese documentation for YY-CHR. There may be later editions of it as well. But yeah, I'll save that for another day. Yeah, so like I was saying, the first thing is just to get your image displaying. So one thing to note about on NTSC, which is the default for the North American NES emulators. So there's two versions. Everyone's probably aware, NTSC and PAL. PAL, you get the complete 256 by 256. NTSC, you only get 256 by 240, and also like the top row and bottom row were cut off. So that's one thing I kept trying to figure out is why am I missing the top row of my images, because it just isn't displayed for NTSC. So yeah, we got our image in, like I talked about, coloring the image, fixing it up right here. What's neat about FCEUX, you can actually go in here and go to debug and PPU viewer. You can actually see the palette side defined right here. So the first row, like I said earlier, is the background palette, and it'll give you actually the hexadecimal codes right there. 37, 27, 07. And then this bottom row is the sprite layer down here. Like that. So you can do this for any game. But it's really helpful when you're trying to figure out what colors are being used in your image. And like I said earlier, the attribute data applies to the 16 by 16 squares. 4 8x8 squares. So here's some other things to consider for touching this up. I went ahead and altered the image. I removed like the background from the image in Gimp so it actually looked better, actually looked like a real NES game. One thing you can do is you can use the Gimp grid feature to draw grid lines. That kind of helps set the attributes and your palette colors right here. When you're trying to color this thing, you can figure out which palette is applied to which area of the image. And that's kind of like what I did over here. So I used the Motorwork font from the old Xbox. First time I found it was with the Xbox Live Indie Games. Is a free font that's free to use. So I put Knox Game Design. So I kind of did the same thing over here. Edited the image, and then I was able to figure out where I needed to apply each of those palettes to have the Knox Game Design text show up as red, green, and cyan at the bottom. And then in my image, I set the background, the color to this bright green, so I knew exactly what the background color was. Then my image is only 3 colors. I have like 2 different skin tone colors, dollar or hexadecimal 35 and hexadecimal 28. Then kind of like this orangish shadow color is hexadecimal 07. And then for the Knox Game Design text, the red text is hexadecimal 16, green text is hexadecimal 1A, and the cyan text is hexadecimal 2C. And one thing I had to touch up is like portion of the image that came in as a transparent color, made those non-transparent. As I said, I used the green for the background. And one thing I didn't do in this game that's used in a lot of NES games is like a checkerboard pattern if you want to blend between 2 colors. And you can probably do that with Gimp pretty easily. Just make a little checkerboard, 1 pixel, or I don't know. I guess a 2x2 texture with two different colors, the two different palette colors. And so this is what our image looks like in Gimp, cleaned up and with the additional text. And one nice thing is like you can click on your color and you can see the 4 different colors that are in the palette. So you can just like click on one of the colors in your palette and say I do 00FF00 for green, and that'll change the background to green. And then you can go into configure grid and change the spacing to 16 by 16 and give it a different, your grid a foreground color. I usually like to use like magenta, something like that. All red and all blue. Okay, and then you have to go into view and I usually do show grid and snap to grid like that. So I can kind of lay out, hey, these are the cells, the 16 by 16 groups that I want to have the different colors. So yeah, you can actually use different palettes for different portions of the image, but your image still has to only be 4 colors. So you got to keep it straight in your mind. Okay, which areas of this image are colored by which palette? And like I said earlier, you set the different palettes using that attribute in the assembly code. Yeah, so let's take a look at the updated program file after it's been compiled. So I kind of have the same thing. Like if you go back here, the second portion of the demo is in Knox 01. And again, I have a build.bat file, creates a NES file in the out directory. I already had a Knox 01 NES in there. So yeah, you can just go open that up. And our Knox 01 demo right there. So there it is. So it's pretty cool to have a picture of myself in a running NES game and got the Knox game design on there. Yeah, so I just wanted to show another example of importing an image. So I got this picture of the Tennessee River, and I believe that's the Henley Street Bridge. So here's some things to remember. So the first thing is your pattern table. You can have 2 16 by 16 tile patterns at one time for 512 total tiles, but the screen displays 960 tiles at one time in the NTSC resolution. As I mentioned earlier, you can compress tiles, you can filter out blank tiles, remove duplicate tiles that can be mirrored, and you can repeat certain background tiles. So that's why sometimes in NES games you see like a photorealistic or a photo image, and it's like in a little square. I'm thinking like in the Ninja Turtle games or like Jackal or many other games, like you just see a little small square for an image, and that's probably why, because you're limited to the amount that you can display at one time. Yeah, so this is the image that I started out with. I think just found this public image of the Tennessee River. I believe that's the Henley Street Bridge, I believe, right there. So yeah, I kind of did the same thing. I reduced the colors down to 4 using the image mode indexed right there. And so right now it's 256 by 256. I additionally reduced it down to 128 by 128, and then I went in to YY-CHR. Yeah, so this is what it looked like in YY-CHR. So this right side is kind of like a zoomed in I don't know what resolution that is. But yeah, you can kind of zoom in that right area. But yeah, just always remember like the first top area is the sprite, and that's where I have like all the characters for the text. The sprite layer, texture layer, then go in one down, and use these arrows to go up and down and to the top, or yeah, you can use the blue arrow down to go down to the background texture layer right there. So that's the bridge right there. So yeah, it's not a perfect job. You could go in here, clean it up, but it's a starting point. So let's go ahead and take a look at this in FCEUX. File, open. Already compiled it earlier. So yeah, I believe that's the Henley Street Bridge, Tennessee River. I got a blue background, so it's not perfect, but you kind of get an idea. And the other thing is, I believe I used a sprite layer to put the Knox game design in there, text, and I actually wrote a little program. Yes, I wrote a little helper program. It's called Stir to NES. Little Python script right here. Basically, it lets you enter a string, and it converts it to uppercase, and then it converts it to the equivalent tiles for each character. So you can use it to paste into your assembly code. So let's exit out of that. So I'm going to do Python stir to NES. I'll type in Knox game design. So this gives you the hexadecimal characters for each of the tiles, and this assumes that it starts out with 0 through 9, then A through Z, starting at location 0. So this is the encoded Knox game design string right there. So if we go back and look, see if I can bring both of these up at the same time. If we look here, here's the code for our third demo that says Knox game design. And so you see I have the Knox game design written out as sprites. So you see 14, 17, 18, 21 generated by our character program. So you can see here's our sprite definitions, the locations right here, but here's our 14, 17, 18, 21. And then we have 10, 0A, 16, 0E. That's game. And then design is 0D, 0E. You can tell like DE right there. 1C for S, 1, 2 for I, 1, 0 for G, and 1, 7 for N. And I was also going to mention, since it's the Nerdy Night demo, you can like press B and A and B to move the K character around, which you'll also see on the upcoming demo. Just kind of an artifact of using that other code. Yes, I want to play some demos of this actually running on real hardware. I recorded these earlier in the other room where I have like all my equipment set up and everything. So the first demo is going to be the PowerPak, second demo is going to be EverDrive, and third is going to be the Analogue Pocket. Okay, so this is the first part of the demo. So the PowerPak uses CF cards, which I don't even know if exist anymore. So here's the PowerPak. You have to have a special reader, which is kind of a pain for the CF cards, but this is like me fumbling trying to put the CF card in the correct way. It's always hard for me to tell the first try which way it goes in, but you just stick that thing in and push that little tab thing in. That's after I've copied the NES files over to the CF card. So here's me putting the PowerPak into the NES. Of course, first time it never works. I always have to jiggle the cartridge around a little bit, and then it comes up. Yeah, so this is the menu right here for the PowerPak. It's kind of hard to see as using my phone to record this. But yeah, put all the Knox game design demo files in this one folder so you can see the Knox 00, 01, 02. That's the first demo. It's interesting on the PowerPak. You get that little artifact at the bottom, probably because I didn't fill in all the tiles at the bottom. So it just kind of goes to shows, like if you develop something in an emulator, you always need to test on hardware too if you want to run it on hardware, just because it may look different. You're not guaranteed it's going to look the same on hardware than it does on the emulator. But you always get confused how to reset the The PowerPak, you got to press power, like reset doesn't do it. You got to press power, then I think press B to get back to the main menu. So this is the second demo, Knox 01, just the image that I cleaned up, and just the picture that I had, and the Knox game design, kind of showing, yeah, it got the right colors. That one actually looks pretty good, pretty close to the emulator, except the little artifacts at the bottom. Probably if I filled in all the bottom with the blank, it probably would have took care of that. And here's the one with the Tennessee River and the Henley Street Bridge in the blue background. So yeah, that one looks pretty close to what it did in the emulator. And there's the Knox game design right there. And there's the K that moves around when you press A and B. So yeah, PowerPak did a pretty good job. I just got the EverDrive for the NES. I believe it's N8 Pro. So this is kind of like an unboxing right here of the EverDrive. It's really nice. I like it. So it uses like standard micro USB or mini. I always get them mixed up. But yeah, just popping this sucker open right here. And that's what it looks like. Regular NES card, EverDrive, N8 by, I don't know how to pronounce that, Curious, KRIKZZ. Here's me opening up the memory cards right there. That is it's always hard to open those suckers up. Yeah, here it is right here. So it is a ultra micro SDHC UHS-I card with adapter. So I never did use that adapter, but yeah, you just stick that little guy in right there. And I've never figured out, I mean, it has a space for like a controller, like a mini USB, and I always think, kind of like with the N64 one that I did, that I'd be able to connect the pack directly with the USB and read off the memory card. But I haven't gotten that to work with this one either. So I always have to use my old handy card reader right here, the PNY USB card reader, to actually load the games on there. Yeah, so this is what the EverDrive looks like. I had to go in and install, update the firmware. So it's pretty easy. You just have to put a file, I think a ELF or something, I can't remember. But you have to put that file on there, then you run this updater. So I'm just going to skip ahead. And yeah, it's an EUF file. And so you just install that from the menu. So yeah, here's the first demo. And it came out pretty good, kind of like the other ones. But again, I didn't fill in all the textures, so it just has a random texture there at the bottom and random attribute data. So that's one change that could be made. It's me trying to get the camera, my phone camera set up again. So yeah, the EverDrive is pretty nice because you just press reset and it goes back to the main menu. You don't have to press power. So this one is different. This one is missing. It's missing the bottom two rows of that image. So I don't know what happened there. Maybe I didn't fill in all the attribute data, or I don't know, because this one came out right on the PowerPak, the retro USB PowerPak, and on the emulator, but it didn't come out the same on the EverDrive. So that's something I should probably look into, figure out why that didn't come out. And here's the final demo, the one of the Henley Street Bridge, Tennessee River. So it came out kind of like all the other ones. And again, you got the K that can move to the left and right. So yeah, that one came out pretty good. There's the EverDrive. And just pop it in, pop it out, like any other NES cart. Okay, and here's the Analogue Pocket. I got this about a year ago. And you can install like cores on this to emulate NES hardware. So it kind of uses the same micro USB as the EverDrive, and I had a 1 terabyte memory card right there. So yeah, just stick that in my handy dandy card reader right there that I've had forever, and copied the files over, and then you just pop that guy back in the Analogue Pocket. And I already had the emulator and everything installed, so if you do try this, there's some setup you got to do to install the emulators, the cores, but it uses FPGA emulation to play NES game files. So you just go to FPGA and go into the NES. I got the Knox game design folder in there and the 3 demos. So here's the first demo. Takes a little while to run, but yeah, this one kind of looks like the retro USB. Looks pretty good with my random palette colors on there. But yeah, it's pretty nice for playing NES game files right there. And just press that little middle button there to exit out, and just quit out of that demo and go back to open FPGA. Then go to Knox 01. It's kind of hard to get the camera focused on that, but takes it a second to load, a few seconds to load. And yeah, there's the one with my picture and Knox game design cleaned up. And then we got the third demo coming up. Quit out of that one. Yeah, so the Analogue Pocket is a nice handheld. I've had it for about a year, and seems like it emulates really good. Yeah, and there's the one with the Henley Street Bridge right there. Yeah, it's kind of hard to get it focused, but there's the moving K again. Move it left and right using A and B. So, yeah, just a simple demo. Just a proof of concept showing that, yeah, you can get a photo image in a NES game and play it on hardware. Yeah, so that's going to wrap it up for Knox Game Design for June 2026. So I'm thinking next month I'm probably going to do, I already started on it, an overview again of actually creating a NES game in 6502 assembly, and looking, kind of just showing how that's done and everything. I did a talk about, it was about 10 years ago, and it is very popular, so I'm going to try to do that again, show how things have come along since then, and show the latest tools and everything. So, but yeah, that's going to wrap it up for this month's thought. So I appreciate everybody out there listening and watching.